Hi, I'm Brandon Smith, and I'm doing the 2014 AP Calc AB free response question number 3, no calc. The function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x equals integral -3 to x f of t dt. Part A is asking us to find g of 3. This graph right here is f. We know that g of x equals the integral of -3 to x f of t dt. The problem tells us though to plug in 3 for x, so we have the integral of -3 to 3. So we look at our graph and make marks on -3 and 3, and this integral is asking us to find the area under the curve. So we want to find the area of this triangle right here and find the area of this small triangle right here. This triangle, we know that the base is 1, 2, 3, 4, 5, and the height is 1, 2, 3, 4. So we use the formula a equals 1/2 base times height, and we know it comes out to 10. Then we want to find the area of this triangle right here. We know that the x value is 3, but we want to find the y value to be accurate. So what you do is you know the point, you want to find the slope of this line, and we know the point 0, 4 and 4, -4. So you find the slope of that, you get -2. Then you plug in your slope, and you end up getting, you do find out that this point right here is -2. So then you find the area, you know the base is 1 and the height is 2. So then you do a equals 1/2 base times height, and you get 1. However, the area under the curve right here is below the x-axis, so it is negative, and this is above, so it is positive. So you get 10 minus 1 equals 9 as g of 3. So part B says on what open intervals contained in -5 to 4 is the graph of g both increasing and concave down. Give a reason for your answer. So to look at this problem, we want to somehow relate this to the graph up here. So what we can do is we can take the derivative of this function g of x equals the integral of -3 to x f of t dt. So if we were to take the derivative of that, we would come across the fundamental theorem of calculus, and this x would go down here and it would become f of x. So f of x, g prime x is equal to f of x, which is this graph right here. So now that we can relate to that, we look at this graph, and to find increasing and decreasing, we look at the slope. So all the points that are above the x-axis, anything above it is going to be increasing because it is a positive slope. Anything below it is a negative slope and it is going to be decreasing. Now to find concavity, what we have to look at is this graph right here, g prime of x or f of x. That graph right there, concavity, anything, if g prime is decreasing, then we know it is concave down. If it is increasing, it's concave up. So from -5 all the way to 2, it is increasing because the slope is positive. So now to find concavity, anything that is decreasing, like this line right here or this line right here, is going to be concave down. So it is increasing and concave down on -5 to -3 and on 0 to 2. We know that answer because g prime is equal to f, and it is positive and decreasing on these intervals. Looking at part C, it says the function h is defined by h of x equals g of x over 5x. Find h prime 3. So to do this, we do the quotient rule, which is low d high minus high d low over low squared. So we do 5x times g prime x minus g of x times 5 all over 5x squared. And now it wants us to find h prime 3, so we plug in 3 for all the x values. So we do 5 times 3, which is 15, g prime 3 minus 5 g of 3 all over 225. And now to find g prime of 3, we look at this graph up here. F of x is the same thing as g prime x. So to find g prime of 3, we go to 3. We found this earlier. It is -2. So we do 15 times -2 to get -30. And then g of 3, we found that in part A, and that was +9. So it's negative 5 times 9, which is negative 45, all over 225. So we get negative 75 over 225, which reduces to negative 1/3. So now looking at part D, the function p is defined by p of x equals f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals negative 1. So to do this problem, we want to find the slope, which is this just the derivative of the function. So we take the derivative of p of x, and we take the derivative of the outside and multiply it by the derivative of the inside, which is just the chain rule. So f prime of x squared minus x times the derivative of the inside, 2x minus 1. Now what we want to do is it specifies that x equals negative 1, so we want to plug in negative 1 for all the x values. So we get f prime of negative 1 times negative 1, which is 1, minus negative 1, times 2 times negative 1, minus 1. So negative 2 minus 1. So we add that all together and we get f prime of 2 times negative 3. So now to find f prime of 2, we want to look at this original graph up here. This is the f graph. So to find f prime, it is just the slope. So we look at point 2 right here, and we see that it is on the line that has a constant slope. That line has a slope of negative 2. So we know that it is going to be negative 2 because the line has a constant slope. So we get negative 2 times negative 3, which is 6, and that concludes the problem. So I would say the hardest part about this problem is basically just relating everything to the graph up above and knowing that g prime of x is the same as f of x. But other than that, I mean, as long as you know your quotient rule, know how to do slope of tangent lines, I don't think it's that difficult of a problem. But if you guys want to get any more practice, you can look at the 2012 FRQ number 3. That has some similar parts to it as this problem. Also, 3.10 talks about slope of tangent lines, and 3.2 discusses the quotient rule. If you don't really know what to do and you're stuck on this problem, just in order to get some points, write out your formulas, just show some work to know that you have some sort of understanding for the problem, and that should get you some points. So thanks for listening, and I hope now you have a better understanding of this problem.